Okay, now the next one, let me give you some example about the inverse. Okay, the inverse. So let use the function f of x equal x squared. Okay, then I try to grab the point and try the inverse of y equal x squared. Okay. Okay, so let's do this. So I have some point here x, f of x equal x squared, and I exchange, find the inverse. Okay, so what is that? So let's talk 0, x squared equals 0. What is the inverse? What is the inverse? So you have 1, 1. Okay, 1 and 1, and you have negative 1 and 1, negative 2 and 1, negative 2 and 4, so 2 and 4. So this one here is y, right? So now what is about inverse? Let me plot all the points here, 0, 0, x, y, okay? So the inverse, so become y and x, okay? Okay. So now I plot the 0, 0, let's say 0 on point A, 0 on point B, 1 and 1, 1 and 1, point C, 2 and 4, 2, 1, 2, 3, 4, 2 and 4, and you have minus 1 and 1, minus 1 and 1 here, minus 1 and 1, so 0 on x, 0 on y, that and 4, point D, and finally minus 2 and 4. Minus 2 and 1, 2, 3 and 4. Okay, I connect, and I have the function y equal x squared. Now how about the inverse? This one 1 and 1. So the inverse in that here, x become y become x. Okay, so negative 2 and 4 become 4 and negative 2. This one become x and y. This y here inverse of that y. Okay. So then I have 1 and negative 1, and get 0, chain the same thing, chain x equal 2, y equal 4 become x equal 4, y equal 2. Now I plot about 4 and minus 2, 1, 2, 3, 4 and minus 2. Okay, 4 and minus 2. So now I check with the line y equal x to see if I have reasonable. I have the inverse function if reflect correctly. Okay, let me try to see if it reflect from here to here, or not. Yeah, the line here, the line y equal x. This is the line y equal x. Okay, let's see if it reflect 4 and 2. This one 4 and 2 with 4 and 2. I'm sorry, 4 and 1, 2 here. So the point here, let's check. I change from 4, x become 4, y become 2. So look like they are inverse, right? Look like, correct? So 1 and 1, so they share the same point here. 0 and 0, they share the same point here. Now minus 1, 1, I change y become x, x become y. 1 and negative 1. So 1 and negative 1 right here. So clearly this is reflect to the line here, right? So that reflect to the line here. Finally we have negative 2 and 4, which is negative 2 and 4 become 4 and negative 2. 1, 2, 3, 4 and negative 2 right here. So this one should reflect the line all the way to that point here and get the right angle, and the distance look the same. So now how I got this one? So I connect this one. Okay, I connect this one, and this one. Okay, so now let's see, this one reflect to that one, this one reflect to that one, this one share the same thing here, this one reflect to that one. So the red one is inverse of the black one. However, we don't consider this a function because the function here is the red one here is not a function, because when you draw the vertical line test, right? Vertical test you go through twice. You cannot have a function. So therefore we call it an inverse relation. Not a function, because the inverse is not function. The original is a function, but the inverse is not a function. So therefore we call this one a relation to that one. Okay. So how to find a function? How to find a function? Give you the same problem here. Okay. Give you the same problem here. So f of x equal x square. So how to find the inverse function, not inverse relation. So in this case we call the restriction. Okay. So the restriction. So we have to restrict the domain of this. For example, in this case I restrict like this. So x is greater than equal 0 only. That means y equal x square only x is greater than 0. The rest we don't know. So therefore I reconstruct the graph here, y equal x square. Okay, like this. So y equal x square, I have the graph like this. Okay, the graph like that. So only x greater than 0, x less than 0 we don't know. So we call the restriction. Okay, this one restriction of x square. So now this one a one-to-one function, because this one x square already the function, but you draw the horizontal test, you go to 1. So this one become, after I restrict the x square, become 1-to-1 function. Now it has an inverse. So take a look at this. So I mark 1 and 1 stay the same, right? This one 0 and 0. 1 and 1 they change, y become x was the same. How about here? 2 and 4. 2 and 4. So now we change to 4 and 2. Okay. 1, 2. Oh, this one. Alright. 1, 2, 1, 2, 3, 4. So now the graph look like this. So 2 and 4. Now I do the inverse, become 4 and become change to 4 and 2, right? Count 1, 2, 3, 4, 1, 2. So the graph become look like this. They share the same point here, the same point here. Here we go. So now after we restrict the function x square in half of this only, so we turn the x square to one function. Therefore we have the inverse function, not relation. Okay. So this one we call the restriction of the function. So x square is not one-to-one. We turn it to the one-to-one. Therefore we have the inverse function. Okay. You can restrict from 1 to infinity. That's fine too, right? Don't need to be greater than 1. You can greater than 1, greater than 2. You still have only 1-to-1 function. Okay.